All right, this video corresponds to the energy lab. So in this lab, we're going to be investigating, with the help of these masses here, how does changing the mass on the gear pedal affect the speed of the rear tire, the tangential speed of the rear tire. And this involves some energy conversion. So at the beginning, we'll have some energy, and at the end, we'll have a different form of energy. And so the equipment that we have here is we have these varying masses that we can weigh. We have this oven mitt that'll help us slow down the tire so we don't burn our hands. We have the crank set at the largest gear in the front and the smallest gear at the back. And we have this speedometer, which will give us the tangential speed of the rear tire. And the way it does this is, as you can see on the tire, we have these different magnets all across in 3 different parts of the tire. And there is a magnet here that's hard to see. It's blocked out. But this magnet records every time a magnet passes by it as the tire spins. And this speedometer translates that as a tangential speed. Now, the speedometer will give us the maximum speed recording of the rear tire. And so at the end, when we drop our masses, we will get some maximum speed output from the rear tire. So in order to perform this experiment, there's a couple things that we need to keep in mind when we're setting it up. There's a level here, a bubble level, that'll help us be consistent with our drop height when we change the masses. And so what we're going to do is we're just going to remove this bolt. We're going to set this aside for a second, and we're going to put on 2 masses. And for safety's sake, we're going to put this bolt back here so that nothing flies off. And we're going to hold it level. I'm gonna, a little further down, and a little further down. There we go. All right, we are level. And so then we just simply drop it. Pay attention to the motion of the discs at the end. And after that's done, we can see that it's hard to see on the directly on the monitor, but we have reached a speed of 14.3 kilometers per hour. Now, we're going to give you the rest of the data for different masses, but the same procedure will be followed for each trial.
And also, I would like to add that the same procedure will follow for all trials, and the masses are dropped from the same height.
Yes.
The height from this position to the table.
Yes. And we will give you the length of this crank set as well.